Connectivity is essential for IoT devices. It's basically the I in Internet of Things. But it also can become very overwhelming and complex very fast. And the reason for that is because there are many ways to transmit information over the air. Different protocols, different modulations, different frequencies, different bandwidths. And all of them exist, all these options, because they each address different aspects of a wireless communication. Some optimize on battery usage, some optimize on the resiliency of the signal. And because IoT devices are so diverse, sometimes you also need to use several types of connectivity. Let's say, for example, Wi-Fi or cellular to have an update on your device, a full firmware. But sometimes you need to use like a lighter one, like LoRaWAN or MIoT or Sigfox, to transmit a little burst of data and run on battery and go to sleep most of the time. Implementing an application that leverages these different types of connectivity can be tricky, but there are options out there. One of them is called Walter. Walter is a small fish in the big pond that IoT connectivity is, but a very interesting one. Dan from DP Technics is here on the IoT Show to tell me everything you want to know about Walter and connecting IoT devices. Hey everyone, this is the IoT Show. I'm Olivier, your host. Today we'll talk, well, Internet of Things, but more particularly, we'll talk cellular connectivity for IoT devices. And for that, we have Dan with us. Dan, how are you?
Hi, I'm fine. Thank you for having me.
Well, thanks for joining us today. So where are you calling from?
I'm calling from Belgium. We're located at the coast here. Sunny weather at the time, but rather cold.
Yeah, well, it's fresh over here. I'm on the West Coast in the north in Seattle, but nice weather. So, well, I'm glad you are here. So let's start with introductions. Who is Dan? And, you know, the company you own, you work with, which is DP Technics, right? That's the name. And
Yeah.
Where you're based, well, you just mentioned that, but then what is it that you do these days?
Yeah, so I'm actually the founder of DP Technics, and I tend to call ourselves IoT developers. And we do IoT projects from idea on paper up to the finished product. And by that, I mean that we do PCB design, we do embedded software, we do the cloud platform that comes with all this IoT devices, and we also do the UI UX part of the design. So the whole IoT ecosystem is incorporated into the company. And me personally, I'm a hardware and embedded programmer enthusiast.
So we can relate, right? Because I've been working close to hardware for a long time. Each time I have the opportunity, I will get back to it. So that's awesome.
Mhm.
So we want to talk about cellular for IoT, right? But before we go into, you know, Walter itself and the solution and your perspective on the use cases, it's great to be using this kind of technology. Let's first explain what kind of cellular technology we're talking about. Are we talking about cellular like for your phone, or this kind of things? Or are we talking at different types of cellular connectivity specific to IoT scenarios?
Mhm. Yeah, cellular is really broad. Of course, everybody knows from older times the 2G with GPRS and Edge. And back then in the day, IoT for devices and on your phone, it was the same thing. But nowadays, with 4G and 5G techniques, on your phone, you really want a lot of data, low latency, but on the Internet of Things side, you typically don't have a lot of data consumption, but you want low power consumption. So the standards are not really comparable. LTE-M and narrowband IoT for devices are focused on long range and low power, whereas LTE Cat 1 to higher categories are focused on high bandwidth and low latency.
Okay. There's this general perception that cellular is expensive, and we'll talk about other option real quick after, in the realm of LP1. But is cellular really expensive? And can you debunk this perception that people have? And is it really piercing? Do you see more and more projects that are using cellular connectivity, whether it's like narrowband IoT or LTE-M?
Mhm. Well, it is the cellular modules themselves are just a little bit more expensive than other technologies such as LoRaWAN and MIoT or Sigfox. But then you need to look at your IoT system as a whole. And when using cellular, it really eases the production in that you can make a single device that works worldwide. And this actually gives cellular the real edge. And when managing and deploying devices worldwide, you also need to factor in this cost of having SKUs for multiple regions in the world. So when comparing this, I would say that cellular is really going to a level where it's on par with other techniques.
Yeah, I hear you. I've been looking closely at my IoT these days, like recently, and that forced me to look closer into LTE-M and NB-IoT. And at some point, I was thinking it's one or the other, but at the end of the day, they all address different use cases, different scenarios. They're all good at something particular, right? Or they all have an aspect that you would prefer rather than the other ones, and that you would weigh higher in your decision making because your use case is very specific. And so that leads to the question, what kind of use cases do you think NB-IoT and LTE-M are better fit rather than LoRaWAN, Sigfox, MIoT that we just mentioned?
Mm-hmm. Well, most important, I think, is where are you going to deploy your products? When you are in a local deployment, like a factory or a farm where you want to deploy a few hundreds or even a few thousands of sensors, then the techniques like LoRa, MIoT, or some meshing techniques, they really shine because you have a high density network on a small geographical location. But when we are looking to stuff like tracker devices, scientific sensors, roadside signs, or stuff like that, that's sparsely distributed over multiple countries, then cellular is really going to shine, especially because it doesn't force you to also do the infrastructure. That's done by the operator for you.
Got it. I know also that the bandwidth is very limited. Like MyOT is ridiculous. Like it's really not much. Yes, the battery will last for 20 years, but you're limited here. So there are scenarios that we're talking more and more around, security, the need to have over-the-air updates. So it's something that when you're using cellular, you basically enable these scenarios where you can't do that with LoRaWAN or with MyOT or Sigfox, right?
Yeah, exactly. In theory, it's possible with these LoRaWAN technologies, but it's just too slow. And also, you have duty cycle limits because you're in unlicensed spectrum. You're not allowed to do what you want. With cellular, on the other hand, you are in licensed spectrum, and that means that everything is well regulated. But the SIM card in the device also allows you to use this spectrum, and you can go to higher bandwidth if you need it. And over-the-air updates are a really good example of that because you see devices are getting smarter every time. They are evolving really fast, and the software running on these devices gets a lot more complex than just sending a value every now and then. They also do post-processing with the values that the sensors are capturing. And this is software that really needs maintenance. Also, you have certificates on the devices that you want to manage. So you really want to have bidirectional communication. And that's something that cellular also really shines in. It's really hard to deploy over-the-air updates in other technologies.
Yeah. So there's so many aspects that need to be taken into consideration when picking one type of connectivity versus another one. So that's really interesting. We'll talk about also local area networks, right? So where you can leverage other types of connectivity with Walter, and we'll talk about that. But a couple last more in terms of use cases. So we talked about bandwidth. We talked about we talked about license versus license-free type of technology, which actually also have an impact on the potential interference, right? So when you're in licensed bandwidth, you actually will be less prone to interferences because it's regulated, and not everyone can start playing around in these frequencies, right? While if you're in a license-free one, where we have the other LP1 like LoRaWAN and others, you might be prone to interferences. So that's another one. One question is, the perception is, a very big battery on a phone will last me for a day if everything is okay, because I do intense exchanges through my data connection, right? So it burns the battery. So IoT devices need to stay on battery for some time, right? Or they are in scenarios where they need to consume very little battery. Can cellular offer that?
Yes, cellular can definitely offer that. But you need to take into account a few things. It's not only the device. Of course, your power management need to be okay, especially your device is going to sleep for a long time. It's going to be on sleep in most of its lifetime. So you need to minimize that power consumption in deep sleep mode. But you also need to take into account some power saving modes that are baked into these newer cellular standards. EDRX and PSM are the most well-known ones. And it is something that tends to be complex because you need to configure this on your device, but also the operator of the network has something to say about it. You can ask as a device, I want to go to sleep for a few days, but then the operator says, no, you can only sleep for 24 hours. And then the software needs to be smart enough to decide, okay, am I going to disconnect or am I going to be able to live with this 24-hour PSM mode, for example? So cellular can definitely do this, but you need to take into account your device, but also your operator selection.
Okay, that makes sense. And there's always something that you have to be proactive, intentional about how you save the battery to last longer. So that's definitely something people have to take into account. Well, that was a nice setup here. That's the context, right? If I were to try and implement or embed cellular connectivity in my design, so what would be the options in terms of types of designs, and what are the ways to do that?
Well, there are actually three ways. For really high volume, it's a chip down approach, but you don't see this often because then you take the cellular chipset, you embed this onto your board, but you also need to take into account the power management of that chipset, external flash, the SIM card management. So it's possible, but it are actually almost only module makers that take this approach. And that brings us to the second way, and that's by using cellular modules. You have them from various vendors like Simcom, Quectel, Sequans, and so on. And these are small modules soldered onto your PCB board, and they make designing cellular a lot easier, but you still have to take into account some RF traces to the antenna, maybe some antenna switching if you want. And the third way is to actually use a module where all that is done for you. You just plug it into a carrier board, connect the antennas, and you don't have to do any RF design anymore. And also most power management will be done for you. So it really depends on the volume that you want to create of your product.
Okay. Well, now you have to introduce Walter, right? Because we set the stage, why cellular for IoT? You explained the different ways of designing cellular into your hardware. How about, using Walter out of the box, right? So tell me a bit about, tell everyone actually about Walter. What is it?
Yeah, my pleasure. So, Walter is our latest module, and it combines local connectivity like Wi Fi and Bluetooth together with cellular connectivity, LTE-M and narrowband IoT, and also positioning. And it does this in a really compact module that you can plug in onto your carrier board. So, Walter is actually an implementation of that third method. And that makes Walter ideally suited for prototyping, but also low to medium volume.
Great. And so you mentioned, a combination of well, first, actually, how do you come up with the Walter name? Right, that's a cute name. I like it. Does it mean anything? Is it an acronym, or is it something you want to keep secret here?
No, I can tell you about it. Like Walter here, I'm in the Dutch speaking part of Belgium, and Walter is a really common name here. It's typically associated with a bit older people, but and so they have a lot of experience. And on the other side, it's in Dutch, it's Walter. In French, it's Walter. In German, it's Walter. So you can speak it in you can pronounce it in every language. And we see a lot of products that have namings with a lot of letters and numbers. Like German cars, they all have
Yeah.
letters and numbers. And we wanted to come up with a name that shows that we are a European Belgian company, like a Dutch name, and also something that's easy to pronounce and remember. Because I'm sure that if I ask you the number of an IC part that you saw a few months ago, that you will not remember it. But if I ask you, what was that cellular module called again, that you will probably
Yeah.
say, yeah, I know one that's called Walter.
That's my buddy Walter. Totally. I like that. People will start calling you Walter at some point, right? If you see your face presenting it all the time, that can happen. So I'm sure you're going to turn around if someone calls Walter in the street now.
Yeah, and I'll listen.
Yeah, totally. So you were mentioning the combination of different types of technology, right? Cellular on one side, and then suddenly you can switch to a local area network to something like Wi-Fi, Bluetooth, or something else. And so that actually triggers a question, which is developers, right? So if I want to send a message, very often I have to make sure that I understand the type of connectivity underneath, right? To know exactly what type of packets I need to send, what type of headers I need to have, and so on, right? So do I need to wake up my module? Do I need to, these kind of things, right? So how do you approach that? Now you have different types of connectivity on the same hardware, on the same module, for developers.
Mm-hmm. Yeah, well, having all these different types of connectivity, it's really important. To have the Wi-Fi and the Bluetooth there, you can use this, of course, to have an uplink to the cloud, but it will be mainly used to configure your device or to interact with local sensors. And then you have the cellular there if you want to have an uplink. Especially with industrial devices, we see that many devices are not allowed to connect to the industrial network of like hospitals, industry, and so on and so on. So having the option is really important. And what we like to do on the software side is to open things up and create libraries that are open source on GitHub that really tend to abstract away all the difficulties. Sending some data to the cloud over Wi-Fi or over a narrowband IoT connection, when looking at it in real deep technical level, it's something totally different. But from a developer perspective, you just want to get your sensor data or your packet data up to the cloud and process it from there. And to make this easy, that's actually our mission with the open source software libraries that we are creating for Walter.
Yeah, so you're simplifying that network connectivity part in terms of how you code for it. I have a little challenge for you here. So these days, MQTT has established itself as a norm. I wouldn't say a standard. I'm saying a norm on purpose, but as something that's used because it simplifies that, point-to-point communication through a broker. So it's like, I don't want to explain MQTT here, but it's very much used. And it is a protocol that runs on top of TCP, and we know that narrowband IoT, for example, is not very friendly with TCP protocols, right? And so that means that this could have an impact on the developers and their code all the way up to the kind of protocols they can or cannot use. Or do you have a solution for that?
Yeah, so you are right, and it's something that's not really well known yet. TCP and narrowband IoT are not friends indeed, and it's actually up to the grace of many operators that it even works. Because narrowband IoT, it does like things like out of order packets, the latency is really high, and a lot of embedded TCP IP stacks are not up to that task. So whenever doing cellular with LTE-M, you can use TCP, but as you are working with a device that can do both and seamless switching between LTE-M and narrowband IoT, you really want to design with the lowest requirements, and that's for NB-IoT, and you want to use UDP. So when you look at that, CoAP is typically the industry standard to do UDP communication together with DTLS for authentication and encryption of your data. But when looking at the cloud perspective, you are absolutely right that MQTT is a king. We see it on AWS, we see it on Azure, we see it on many of the IoT platforms that are currently in use. And when you come to them and say, hey, I want to send you a CoAP message, they do like, okay, but I don't know how to handle this. So to come up with a solution for this issue, we have extended our Blue Cherry Cloud solution with a transparent proxy between the two protocols. That means that from a device side perspective, you do publish subscribe in as if it would be MQTT, but then we translate this into CoAP plus DTLS, send it to the Blue Cherry Cloud, which is an in-between, and then the Blue Cherry Cloud connects to the broker of your choice and forwards this data as an MQTT packet. So from programmer to the cloud of choice, it's actually as if it would be MQTT, but underneath you are using CoAP plus DTLS to do the actual transmission.
Brilliant, brilliant. I thought I would kind of trick you into that one, but you got me actually. Good. I like that. No, you thought of it all actually, or you are actually really addressing this connectivity problem. There is an extension to the connectivity that very like most, or if not all, customers care about, which is the device management. Having a device connected, having the protocol translated so that you can lend the data, or talk to the right types of services in the back end is another things you're addressing. But in general, I'm curious to know also if Blue Cherry, which is the cloud part of your solution that you described, takes care of some level of device management. The things that customers need to understand here if they were to consider Walter.
Yeah. So Blue Cherry, at first, we are all about being open and giving people choice. So it needs to be clear that we want to make a great offering with Blue Cherry, but it's not obliged in any way. Like with Walter and Blue Cherry are two different things. And of course, they work perfectly together, but we want to offer choice. And besides that, of course, we have the MQTT CoAP proxy, and we also have what we call device fleet management, and it comes with over-the-air update baked in. Over-the-air update for Walter's application processor, which is the ESP32S3, and also over-the-air update for the Sequence modem, which is inside. So you can push two different updates to the devices. And on the other hand, you can also use Blue Cherry to run your application. But what we want to do with Blue Cherry is just offer a solution to host your application into the cloud and not forcing you into using some kind of dashboarding, because there are a lot of great dashboarding solutions out there. We don't want to be a new dashboarding solution. We're just about getting your data to where you want it to be and to offer you solutions to do this over-the-air update management, to locate your devices, and so on and so on. But if you want to have your UI there to build your APIs, you just build them with the tools that you like, and then we can host them inside the Blue Cherry platform.
So flexibility here is the key word, as I understand it, because we're about to see a short demo. You're going to show us the board, and then we'll look at data flowing into Blue Cherry, and we'll see a dashboard, right? So, but this is really great for proof of concept for demos. But as you were saying, the goal is not to force you into this dashboarding environment, but instead to give you that connectivity, device management, security aspects of it, and then open up to other systems by pushing data for richer, dashboarding as well as analytics for the data and so on, right? So let's look at the board. Let's if you can just describe it to us real quick, and then we'll look at this data flowing into Blue Cherry.
Yeah. So I have Walter connected here to the Walter Fields development board. We see Walter Fields as some kind of a reference design because the small Walter module that you see here, it's designed to be plugged into a carrier board. You can use it standalone as a tracker, but you actually want to have things like battery charging management, some sensors that you want to connect. And with the open source Walter Fields, we show like this is possible. So we have quite an extensive power management with an MPPT charger, with quite a broad input range between 2.5 and 36 volts input. So this allows you to connect small to really large solar panels, batteries like lithium ion, lithium iron phosphate, lead acid, and so on. And besides that, we have a lot of built-in sensors. We have temperature and humidity, we have air pressure, we have 6 degrees of freedom IMU, and we also have a slot for the Sensirion absolute CO2 sensor, because air quality is really a nice use case for cellular to have this dispersed sensors. And besides that, we also provide a lot of connectivity options. We have RS-232, RS-485, but also SDI-12, CAN bus, some analog inputs. And of course, we also have an SD card there for local storage. There is some built-in storage in Walter. There's 16 megabytes of flash in Walter, but if your logger wants to have high-resolution data, then you can use the SD card to capture it locally. So on the demonstration here, I have connected up the Walter Fields board to a 20-volt power supply to simulate the solar panel. And it's here in Belgium, transmitting the data over LTE-M to our Blue Cherry server. And then in Blue Cherry, we have this small dashboarding demo. It's showing all the data points that are coming from the board. And it's also a good demonstration for the low power, because we see a transmission interval of 5 minutes. And in between these 5 minutes, the board actually goes into power saving mode, PSM mode. And as you can see, we have temperature, humidity, air pressure, CO2. You'll probably see the CO2 going up during the show because I have switched off my ventilation. So you can get a lot of information from that. And besides all the sensors, we also show the power input. So you can see that there is this 20-volt power supply connected. You can see that we're drawing about 0.04 amps from it. And that's, of course, it's a snapshot. So that's when it's transmitting the data. In real life, in PSM mode, Walter only consumes 9.8 microamps of current. So that means that on a single 18650 cell, of 3000 milliamp hours, we can sleep for 32 years. How wonderful would that be if we could sleep so long as a
Yeah,
human?
exactly. It was, but that's interesting you're saying that, because there's a lot of scenarios where these sensors might be deployed in a remote location that you don't have access to, or very rare access to, and you don't have like to care about it. I have some devices at home. I have like a couple of motorized shades. One
Mhm.
is high up there at like 6-7 meters from the ground, and I have to go and recharge it once a year. And it's okay, once a year is not too bad, right, for something that
Mhm.
that is that useful. But still, you cannot do that on all the hundreds of, if not thousands of devices you're going to deploy that need to run on battery for a long time, right? So you need to be able to rely on the fact that they're just going to work.
Yeah, yeah, exactly. And that's also, um, of course, having a good power management on the board is important, but also having a powerful processor like the ESP32 helps with that. And that could sound a bit strange at first, but you can save a lot of power by locally processing your data first. Like, for example, if you are monitoring a tank level, you can measure the level every hour, but only send the level like once a day, or even more dynamically, only when the level has changed, and you send a "Hey, I'm still alive" packet every 7 days. And that can mean a difference of 1 year battery lifetime or 8 years battery lifetime. So having this powerful ESP32 processor really helps with that.
Yeah, agreed. Cool. So that's a lot to digest, I would say, but in a good way, right? So you just shared a lot of information about not just Walter, but also at large the importance of considering cellular connectivity for your IoT project. And you debunked a couple of the myths, right? It's not just about the price. It's not just about the volume either. And it's not about the battery life either, because Cellular is good at all of these ones. So potentially addressing the specific use cases we described today. Awesome. So what can people do now? They want to get to know Walter, right? It's good buddy. They want to get to know him and try it out. So what do you recommend here?
Yeah, well, glad you asked. We have been working on Walter for 1 year, and we are now launching it through crowd supply. It also shows our commitment to being open source. So I would say head over to crowd supply, check out our campaign. You will also find all data there, the
Yeah.
schematics, links to our libraries, examples, and so on. And after crowd supply has been completed, it will be available through Mauser.
There you go. I like all the you just said. I think all the names, the fact that it's open source at heart, the flexibility you're offering developers as well to abstract the different types of connectivity, which is super important to the point where you will have this proxy for MQTT to CoAP conversion so that it's even more transparent. It can continue and reuse existing code that is MQTT based on their device to send data up to the cloud. So that's fantastic. Dan, I really appreciate your time today. I think people will be more than interested to learn more about Walter. We'll put some links down there. Have a great day, all. Thanks again for coming, Dan.
Yeah, thank you for having me at the show. It was really great to be here, and nice talking to you.
Same here.
Bye.
Bye.